In this video, we will be discussing the James Webb Telescope and its contributions to the scientific community and why it is such an important breakthrough. We will begin by explaining what James Webb is and how it works. We will provide some historical background on the telescope and other recent developments to provide context for Webb. We will explain what Webb has discovered, and we will explain why these discoveries are so important.
Part of what makes the James Webb Telescope so interesting, unique, and important to the scientific community is not only that which it has contributed thus far in terms of photographs, new knowledge, etc., but the sheer risk involved in the mission itself proves the scientific community's dedication to further advancement of knowledge, but also the costs involved, both economically and in the number of man hours put in, and what it will do for the scientific community overall. To begin with, the telescope is incredibly expensive, costing upwards of $10 billion. And many people question why such an expensive instrument is needed. Well, to begin with, the telescope is massive, well over 20 feet in diameter, and requires true 24-karat gold in its mirrors. And there are many mirrors in order to see to the most expansive parts of the universe, which we have not yet ever seen before. But we need the highest quality materials in order to do this, which in turn requires a lot of money. Additionally, the complexity of the instrument itself requires the best engineers to design it, which in turn adds to the cost. The telescope must be able to fold in on itself and unfold remotely in space so that it can be put into a space module and launched, and when beyond Earth's atmosphere and in the realm of the universe, it must be able to unfold on its own and place its mirrors in the appropriate positions. And with the slightest miscalibration of the mirrors, then the telescope will not be able to properly perform its functions. It is this risk associated with the telescope that has many people questioning why we need such an instrument, one that might not perform adequately and cost so much money simply to produce. But scientists are quick to answer this, and that they need the Webb telescope because it is a different instrument. There's a common misconception that the Webb telescope is but a larger version of Hubble, that it's just an advanced version of the Hubble telescope, but this is not true. Scientists are quick to point out that it is an altogether different instrument because it can see things that Hubble can't, not because it's more advanced, but because it is designed to see things that Hubble was never built to do. And so because it is a different instrument, it allows us a different insight into the origins of the galaxy and the ongoing expansion of the universe. And this is why the risks, the cost, and the complexity of the Hubble telescope play into its uniqueness and its necessity in the scientific advancement of our understanding of the universe.
The James Webb Telescope is the largest and most powerful space telescope to be built, being as tall as a three-story building and as long as a tennis court. The telescope will be able to see farther and more clearly than any other telescope before. Its express goal is to complement and enhance the discoveries made by Hubble telescope. However, it is already doing so much more than merely complementing the achievements of Hubble. It is making brand new discoveries of its own that change the way we see the universe literally. The Webb telescope's ability to peer back into the universe set it apart from any other astronomical observatory today. And as it moves through space approximately 1 million miles from Earth, it will be able to help scientists understand previously enigmatic issues regarding the cosmos. And it's this position so far from Earth that is key to its clarity, giving it the best vantage point to look into the vastness of space, while also keeping its instruments cold enough to continuously operate. Throughout the ages, man has been enraptured by the stars, and our fascination with the universe beyond the confines of the atmosphere has driven humanity to try and create tools and mechanisms by which we can see more and thus know more about the universe. It is this drive for knowledge that produced the telescope, the very first one, as we understand a telescope to be, being produced in what is now the Netherlands in 1608. It would quickly spread throughout Europe and become refined and popularized by the famous Italian scientist Galileo Galilei. From this point on, telescopes would grow in size, clarity, and allow people to increasingly see farther into the world beyond our own, one without limits, and it would change how we saw our place in the universe. Eventually, we would make it to a point where we could use the telescope to help establish the heliocentric theory and prove Einstein's theory of relativity. In more recent years, telescopes have been used by scientists to try and determine the nature of the universe and see to what degree it's still expanding, how old it is, and what the life of a galaxy looks like, among other questions. One instrumental tool in this has been the Hubble Space Telescope, which up to the launch of the Webb telescope was able to see the earliest known galaxies, some 13 billion years ago, and had the highest precision ability of any telescopic instrument. Its contributions to science help teach us that light can be displaced on the red end of the spectrum and the approximate age of the universe. This is a big accomplishment to try and top, and it seems the James Webb Telescope is already doing just that. The telescope is providing new information about the early universe that was previously unknown to the scientific community. One of the developments shows that early galaxies were less irregular in composition than previously thought, and revealed that galaxy formation post-Big Bang might have occurred more rapidly than previously thought. This contradicts the line of evidence produced by Hubble that stated early galaxies were inherently irregular in shape and composition. But with Webb, we are able to see that some of these early galaxies even take on a disk shape, which was thought only to be reserved for galaxies formed well after the Big Bang. Additionally, the rate of star formation in these early galaxies, which are approximated to be at least 100 times smaller than the Milky Way, is astonishingly high. So high, in fact, that the stars in these galaxies have 1 billion the mass collectively of our Sun. But how is Webb able to see this? By the use of its cutting-edge infrared camera, which allows it to see through the gas and dust-filled systems and see the stars as they form. The Carina Nebula, for example, is beginning to form new stars as the nebula collapses into hot pockets, as well as being the site of a recently deceased star. In this, Webb will be able to help scientists piece together the stories of these stars in their lifetimes, giving greater insight into their formation and eventual demise. Webb has also shed light on galaxy size, indicating that some of the galaxies which with the use of Hubble seemed immense are in fact much smaller than previously thought to be. These galaxies are part of what is known as the cosmic noon, a period in the universe's history where the most light was produced some 3 billion years ago after the Big Bang. But since these galaxies are much smaller, it potentially changes the whole way we think about how galaxy sizes evolve over time. Initially, with the Hubble images, we believed that galaxies started out small and grew bigger as time went on. However, with these new images, we see that there was missing information in regards to the aforementioned understanding, which is what led scientists to believe the galaxy size evolution might be more complicated than previously thought. The Webb telescope also is being used to study other planets and their atmospheres. Using the telescope's enhanced ability to see light variations, we can determine the elemental makeup of their atmospheres. The reason this can be done is that when a planet passes in front of its parent star, the light passing through its atmosphere changes based upon the composition of the atmosphere. Webb also has been used to look more in depth at potentially habitable exoplanets and determine everything from traces of water to carbon to oxygen ratios. The Webb telescope provides for the scientific community a wealth of new information which both enhances and changes the way we think about the universe and previous conceptions regarding it. As discussed, the discoveries made by Webb are numerous in number and substantial in impact. But what actually does this tell us, and what have we learned from this? To begin, we have images now of star formation and disintegration, giving science new knowledge of the previously unseeable event. We now have higher resolution images of some of the earliest known galaxies, which changes the way science understands the rate at which the universe formed and how quickly galaxies formed organized structures with regular composition. It has given us new insights into planets not so different from Earth and many other discoveries that shed new light on some of the most pressing questions. This is why the James Webb Telescope is such an incredible scientific breakthrough, and more people should be aware of its contributions.